Okay, question 7. In the examination, a candidate is required to select any 7 questions from 10. So the first part of this is fairly straightforward. How do you select 7 out of 10? So you're using your calculator and your 10 C7 button, and you do that, and you get 120. So there's 120 ways that you can select 7 from 10. So, like, incidentally, right? If this question said in an examination, a candidate is required to answer 10 questions from 10, how many ways can they complete the exam? Well, that would be different, right? That would be 10 factorial. If he has to answer 10 questions, and you just simply, well, how many ways could he complete the exam? So he could start at question 1, then he could jump to question 5, question 7, back to question 2. Okay, that would be 10 factorial, which I'll tell you now is equal to 3, 6, 2, 8, 8, 0, 0. Now when you press this 10C button, 10C7 button, what you're actually doing there is your calculator is putting in 10 factorial. Over here, calculator is putting in 10 factorial, and then it's dividing by 7 factorial and 3 factorial. When you use your P button, 10P7, it would just be saying 10 factorial divided by 3 factorial. So this 120, if we just look at that there, it's 10 by 9 by 8 by 7 by 6 by 5 by 4 by 3 by 2 by 1 over 3 by 2 by 1, 7 by 6 by 5 by 4 by 3 by 2 by 1. So you're getting 7's cancel, 6, 5, 4, 3, 2, 1, and you're left with 3, 2, and 1 on the bottom, 10, 9, and 8. 10, 9, and 8 is giving you 720, and 3, 2, and 1 is giving you 6. And that's where the 120 comes from. Just so you know what these buttons do. The permutation would give you a larger answer. You're getting 10 factorial divided by 3 factorial. So you're left with 10 by 9 by 8 by 7 by 6 by 5 by 4. And that's why your 10P7 is a much larger answer. 10P7, it's 604,800. Because it would consider the numbers 1, 2, 3, 4, 5, and 6, and the numbers 7, 6, 5, 4, 3, 2, and 1. Like the question, sorry, 1, 2, 3, 4, 5, and 6, and 7, 6, 5, 4, 3, 2, and 1 to be different different selections, while combination would consider it to be the same selection, right? So no harm to be aware that this 10C7 is actually going through all of this, right? It's going through all of this. So, and remember, this here, the top line here, 10 by 9 by 8 by 7, that's the fundamental principle of counting in action. All right, how many total ways were there to answer the exam? So these formulas, yeah, they're great to, these little buttons on the calculators, it's great to be able to throw them out and use them, but you need to kind of to understand where they're going. So for the second part, it says how many of the selections contain the first and second questions. So if we come over here and think back to the total number of ways the exam could have been answered, this here 10 represented there were 10 choices to be made at the start, followed by 9 choices. But if we go now and look at question 2, how many of the selections contain the first and second question? Well, there is no choice to make if you're selecting the first one, and there's no choice to make. So these numbers would be 1 by 1, and then it becomes a question of how can I choose 5 questions from the remaining 8. So 1 multiplied by 1 multiplied by 8c5. And 8c5 is equal to 56. So 56 by 1 is 56. And the next part, now calculate the probability that the candidate selects both the first question. So this is going to be this over this. If they select both, there's 56 ways that they can select both the first and second question. The last part, at least one of the first 2 questions. Okay, so there's 120 ways that they can choose 7 questions from 10. So just think about this for a second. 56 of them are going to contain the first and second question. So that leaves us with 64. Now out of these 64, a huge portion are going to contain one of the first 2 only. Okay, and then a much smaller portion of them will contain neither of the first 2. So that'll give you an idea before you do the question of your answer. Like, so a huge portion of them is going to contain one of these. So a much smaller portion of them will contain neither of them. So really that's the key to answering the question. So your question is going to be 1 minus the probability of neither question 1 or 2. So how do you work out the probability of neither? So there's 10 questions. And the first 2 are out. The question suddenly becomes, what's the probability of picking 7 out of these remaining 8? How many ways would we pick 7 from 8? So it's 8C8. So we'll put that in our calculator. 8C8. Sorry, 8C7 is 8. So there's 8 ways that you can pick 7 from 8. So the probability of selecting neither is going to be 8 out of 120. Okay, so out of the 120 ways they can select 7, 8 of them are going to not contain the first 2 questions. So 1 minus 8 over 20 is going to be our probability. So 120 over 120 minus 8 over 120 is equal to 112 over 120. And that can be simplified down to 112 over 120, 14 over 15. So I went off on a bit of tangent there at the start, but no harm to understand what these buttons are doing. So just to say that again, 10C7 is going to be 10 factorial over 7 factorial by 3 factorial, and 10P7 would be 10 factorial over 3 factorial. And if you're wondering where the 3 comes from, the 3 is 10 minus 7. So, and these buttons here didn't always exist on the calculator. The factorial button did. So if you're old school, that's the way you would have learned how to do this stuff.